Greetings everyone, this is the AB Calculus BC free response question number 6 from 2018. So here it is. Please pause the video, go try this before you watch the solution. You'll be much better prepared to understand it, and you'll push your knowledge further than you would if you just watch what I do. So we're given a Maclaurin series for the natural log of 1 plus x, and that's, as shown there. And it says on its interval of convergence, the series converges to the natural log of x plus 1. So they're being a little bit, ultra specific here, making sure they're not misrepresenting the mathematics. Let f be the function defined by f of x equals x times the natural log of the quantity 1 plus x over 3. And in part A, they want us to write the first 4 non-zero terms and the general term for the Maclaurin series for f. So in this example here, they don't want you to use the definition of Maclaurin series. They want you to use what in our textbook comes from section 8.6. They want us to use algebra to develop this. There's also the techniques of using some integral and differential calculus to come up with new series, but that's not going to be needed here. So if you notice, in place of x in the original expression, we have now x over 3. So what we're going to do is we're going to replace all the x's in the series here with x over 3 in the first 4 non-zero terms and the general term. And then after that, we also have this extra factor of x here that's being multiplied by the function, the natural log function. So then we're going to distribute that x to each term in the series. We're going to multiply through by that x. So it's a pretty straightforward algebra question that we want to see that you can manipulate and create a new series from an old one using algebra. So let's get to it. Alright, so there's the series. Excuse the right hand side of the series. I was running out of space and I had to squeeze some things on there. So our series for f, again, as I just mentioned on the other screen, I'm going to replace, well, I'm going to do this in 2 steps here. Let me put an x here for the x that's a factor that we're multiplying by, and I'll distribute it later. We're going to replace x in every single term with x over 3. So I'm going to end up with x over 3 minus, I'm going to try to do this small so I don't run out of space and close together. Now the x over 3 is going to be squared, so it's going to end up with x squared over 9, or 2 times 3 squared, and then plus x cubed over 2, no, I'm sorry, it's a 3 times 3 cubed. Now of course we could simplify that to 3 to the 4th, but I'm going to leave it like that just for the pattern's sake. X to the 4th over 4 times 3 to the 4th, and then the general term plus dot 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 plus negative 1 to the n plus 1. That part is unaffected by what we're doing. And then we'll have x to the n over n times 3 to the n plus dot dot dot, and then close the parentheses. And so the last thing we need to do is just distribute that x. And I mean, technically you shouldn't have to, but they want the first 4 non-zero terms, so you should. I'm going to correct that. Please multiply this out, because if you don't, I think you're not going to match the pattern they want, and they might not give you credit. So we're going to get x squared over 3 minus x cubed over 2 times 3 squared plus x to the 4th over 3 times 3 cubed minus x to the 5th over 4 times 3 to the 4th plus dot 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 plus negative 1 to the n plus 1 x to the n plus 1 over n times 3 to the n plus dot dot dot. Alright, so that's it for answer A. I think it's a 2-point question. Yeah, you get 1 point for the first 4 terms and 1 point for the general term. Alright, part B is the one where the bulk of the points for this question comes from. It's worth 5 points. And let's clear off some mess here. It says, determine the interval of convergence for the Maclaurin series for F. Show the work that leads to your answer. Now, they give you two different solutions if you look at the solution guide. And if you know the natural log of 1 plus x has an interval of convergence where the magnitude of x is less than 1, then you can go ahead and take the magnitude of x plus 3 and let that be less than 1. And that'll be, and then test endpoints, and you'll be able to come to the conclusion that you need to come to. I'm going to use the ratio test for this. I'm actually going to pause the video to set up the ratio for the ratio test, so you don't have to see me writing it. Alright, so remember for the ratio test, when we want to set that up, we need the limit as it goes to infinity, we need absolute value. You don't really need the -1 to the powers, but I put them in there just for, I guess, completeness. I don't think they better not require that to happen, or to be there. And then we make n plus 1, and then that's our first term that we put here. This is x to the n plus 1, so change all the n's to n plus 1s, and then divided by x, the original, the nth term, so leaving all the n's really the same. I guess multiplied by the reciprocal here. So, yeah, so these are going to go away because of the absolute value symbols. Those don't need to be there. The x to the n plus 1 and x to the n plus 2 are going to cancel, leaving just an x up here. This is going to cancel with this, leaving just a 3 down over here. And so then this becomes the limit as n approaches infinity. Don't drop the absolute value symbol yet here. So we have n times x over 3 times n plus 1, which, because n is going to infinity, the n over n plus 1 is heading to the same place. This becomes just the absolute value of x over 3, and we need that to be less than 1. Okay, so from this point over here, we just got a little bit of algebra to do. So that means, since 3 is already non-negative, we can make this the absolute value of x over 3 is less than 1. I'll squeeze this on this screen, which implies that the absolute value of x is less than 3. So the interval of convergence as of right now is the open interval. Since this is a Maclaurin series, it's centered at 0. Maybe I should remind you this by writing that out. So since Maclaurin series center is 0, we move the radius of convergence, which in this case is the 3. We move 3 units to the left and 3 units to the right, and our potential interval of convergence here starts with the open interval -3, 3. Now we just need to test the endpoints to see if the series converges at the endpoints. So I paused the video to go kind of write down some things on the next screen. Part of what they're trying to test for you on the rest of this problem after you've set up the ratio test to find the interval of convergence is how well you know your other series convergence tests. So when you're testing the endpoints here, try to show off some of that knowledge so that you can get full credit for this part. So we're going to test the endpoints. So if x is equal to -3, then we just substitute -3 in for x in the expression for the general term of the series. And we want to see what kind of series this is. Now, if we simplify this, because we have in the in this parentheses here, we have a -1 raised to the n plus 1, besides the 3 being raised to the -n plus 1, we're going to end up with, from this -1 to the n plus 1 times the -1 that comes from here to the n plus 1, that's always going to be the same sign. So it's always going to be 1 times 1 or -1 times -1. So those are going to go away because there's always going to come out to be +1. And we're going to be left with 3 to the n plus 1 over n times 3 to the n, which we can simplify further. This becomes, because we cancel out most of the 3's, we're going to end up with 3 over n. Now this can be thought of, we could factor out that 3 times 1 over n, And of course, we should all recognize this as the harmonic series. So we could say this diverges by comparison to the harmonic series. Alright, now going on to when x equals 3. So in this example here, there is no -1 times the 3 inside the parentheses here anymore. That's gone. And so we're still going to have the -1 to the n plus 1 be here in this part of the expression. And we know most of the 3's are going to cancel, so this is going to be 3 over n that's left. And we could factor out that 3 again and get 3 times the sum -1 to the n plus 1. And this is the alternating harmonic series. And so we could say this converges by the alternating series test. Notice that I'm using terminology from the earlier series stuff to express the answer. They love this. They're going to eat this up. You're going to get some good credit for this. So the interval of convergence, I'm going to be sloppy here, I apologize. Convergence is, we said at -3 we diverged, and at 3 it converged, so it's going to be half open, half closed like this. Alright, now we only have part D left. So let's go way back here. Let P sub 4 of x be the 4th degree Taylor polynomial for f about x equals 0. Use the alternating series error bound to find an upper bound for the absolute value of P sub 4 of 2 minus f of 2. So this is just r sub 4. And we saw that the magnitude of r sub 4, because the absolute value is there, we saw that this was going to be less than or equal to the n plus first term, which is going to be a sub 5. So what we need is the 5th term of the series, the one that's going to come after this one, but based on, for this, okay, based on this series here, I'm just circling the 4th term here, so we're going to need the one that comes after for the series that we created for f, okay. And so, let me go back, sorry, one more right here. So again, P sub 4 is the 4th degree Taylor polynomial, so we need the one that comes after the 4th degree term, so we're going to need this x to the 5th over 4 times 3 to the 4th. I should have wrote this out ahead of time. X to the 5th over, I'm going to pause it and go copy this down. Alright, so there's the term. Now again, we're doing this at 2, so this P sub 4 of 2 minus f of 2 in magnitude is going to be bounded by the absolute value of, now plug in 2 for x, and then this is going to equal, well, 2 to the 5th divided by 4, which is 2 squared, is going to be 2 to the 3rd, so we're going to be left with 8 on top here. 3 to the 4th is 81, and there is the bound that they're looking for. That's it. Just got to look at the next term. Well, that's what the alternating series test tells us. Look at the next term, and plug in 2, and there you go. Simplify it in this case. Go study.